Hi, in this video, I will be showing you problem number 14 of chapter 9, section 5. Solve the differential equation t times ln t times dr by dt plus r equal to 5t e to the t. So the two variables involved are r and t. So first we want to determine what type of differential equation is this. Is it separable or linear? So if we divide the whole thing by t times ln t, so we get t ln t times dr by dt plus r equal to 5t e to the t. Divide both sides by t ln t. So it is t ln t and t ln of t. Assuming t is more than 1 and it's positive. So we get here dr by dt plus 1 over t ln t times r equal to 5 e to the t over ln t. So does this look like a linear equation? Linear differential equation. So linear differential equation is of the type dy by dx plus a function of x, y equal to a function of x. So here t is the independent variable. So you get, and r is a dependent variable. So you get dr by dt plus 1 over t ln t r equal to 5 e to the t ln t looks like look exactly like a linear equation. So it's linear differential equation. So once you determine that, we have to determine the integrating factor. We'll call this equation as equation 1. Integrating factor is a function of t in this case. It will be integral e to the p of t dt. So we notice here this expression is p of t, and then this expression is q of t. So it will be integral equal to e to the exponent integral p of t, which is 1 over t ln t dt. We'll solve for integral 1 over t ln t, and then we'll get back to this I of t. So this is integrating factor. So how to determine integral of 1 over t ln of t dt? We'll apply the u sub, u equal to ln t, then du equal to 1 over t dt. So our integrating factor I of t, before that we will have to just find out what this integral is. So it is integral 1 over t ln t dt can be written as 1 over ln t 1 over t dt. It will be integral 1 over u 1 over t dt from here, and this part it's just du. So ultimately it becomes just ln of u or ln of t, because our u is equal to ln of t. So it's ln of t. So that is the integral 3. So getting back to integrating factor, which is step 2, which is e to the exponent integral of 1 over t ln t dt This is from equation 2, from expression 2. So that will be e to the, this integral is ln of t, which is what we found out. This is the value of 3. So this will be equal to e and ln are inverses, so it is just ln of t. So the integrating factor for this problem is ln of t. The purpose of finding the integrating factor is to only make the linear differential equation, the left-hand side of which, left-hand side of the linear differential equation will become a perfect differential by multiplying by the integrating factor. That's the very idea of finding the integrating factor. So we will take equation 1. So multiply equation 1 by the integrating factor. So we get ln of t multiplied by the left hand side of 1 equal to ln of t multiplied by the right hand side of 1. The left hand side of 1 is dr by dt plus 1 over t ln t times r equal to ln t times the right hand side of 1, which is 5 e to the t over ln t. Here ln t get cancelled out. So you get ln of t dr by dt plus, if you distribute, ln t get cancelled out. So 1 over t times r equal to 5 e to the t. Once you multiply that, you can write the left hand side as d by dt of the integrating factor times r. This is equal to 5 e to the t. We can check the left hand side. Left hand side is the product of two functions. So if you differentiate, it is ln t times dr by dt plus r times derivative of ln t, which is 1 over t, which is exactly what we have on the left hand side. So once you determine the ln t and you multiply by the differential equation, linear differential equation by the integrating factor, the left hand side would automatically become a derivative of the integrating factor times the dependent variable. Okay, now integrate both sides. Integrate both sides. Maybe we can name it as equation 4. Integrate both sides of 4. So it is integral of derivative of with respect to t, then integral of 5 e to the t dt. Derivative and integral are inverse processes, so you just get the integrand back, which is equal to 5 e to the t plus c. If you solve for the variable r, it is 5 e to the t plus c over ln t. So r is the solution to the problem, and r is equal to 5 e to the t plus c over ln t. Hope this video helps.